Hi, this is Lisa Knight, and this is your weekly update. I have graded your Module 2 assignments. I'm going to go over some of the key points from Homework 1 and from your lab. So first, starting with your Homework 1, I want to remind you that you need to read your instructions carefully and that all your answers should be rounded to 3 significant digits. Also, you should complete the document and scan it as a PDF or a Word. Most of you did that, but when you upload it as images, sometimes Blackboard doesn't open it up. Um, I'm going to post a rubric for you guys, but so that you'll have access to it. But the things that were consistently a problem, I'm going to go over. So in number 1, most people were good at finding displacement and distance, and they were good at finding average speed and average velocity. The big thing was that you need to remember that when you're in a physics class, all your answers need to be in standard units. I should not have to tell you that because we went over that in chapter 1. I did take off a point for it, but not a whole bunch of points. So your speeds should be in meters per second, your distances in meters, and your accelerations in meters per second squared. In number 2, you were slowing down. So remember that if you slow down, you should be getting a negative acceleration. If you did not get a negative acceleration, then I took off a point for that. So let's talk about this problem because this was probably the most conceptually hard problem on the problem set. The car is traveling at a constant speed for 7 seconds. So that means that every second of those 7 seconds is going 20 meters. So you can tell kind of how far it went already. You know that after 1 second it had a distance of 20, after 2 seconds it had gone a total of 40, and so forth. So that after 7 seconds it had gone 20 meters per second times 7, or 140 meters. Then it comes to a stop. So now you're going to use a kinematics equation because it's accelerating at negative 6.67 meters per second squared. And it does that for 3 seconds. So it starts out with an initial velocity of 20 and it comes to a stop at 0. And it has an acceleration of negative 6.67 meters per second squared. And it does that over a time of 3 seconds. So with that in mind, I need to pick a kinematics equation. And you have a choice. You could use one that has acceleration in it, or you could use one without acceleration. I chose to use the one without acceleration because that is something that I had calculated. And what if I had calculated it incorrectly? So that formula is distance equals 1/2 of the initial velocity plus the final velocity times time. So that would be 1/2 of 20 times 3, which is 30 meters. So remember, I want the total distance, right? He went 140 meters when he was traveling at 20 meters per second, plus I have to add 30 meters per second for the distance that it took him to stop. So one thing that may help you is if you kind of sketch out a picture of what's going on, because really with these problems you have to conceptualize what's going on in the real world and then put the math to it. All right, so most of you guys did a pretty good job figuring out number 3. You know that you are traveling, you're going from 100 meters per second to 0 in 7 seconds. So you have the initial velocity, the final velocity, and the time. And you just need to plug it into the same formula that you just used above. 350 meters should be the answer. And I would like to mention that all your answers need to be in 3 significant digits. So 350 is 3 significant digits in this case because it has meters on it. A rifle fires a bullet, and when it leaves the barrel, it has 125 meters per second, and the barrel is 45 centimeters long. So when we make a list of what we know, and this is how you should always start out these problems, I know that it leaves the barrel at 125 meters per second, and I know that it traveled 45 centimeters before it did that. So X is 0.45 meters. So I have to put that in as a is meters, right? Because everything has to be in standard units. And I know that to begin with, inside that, so we're in the barrel now. When it leaves the barrel, it's moving at 125 meters per second. That is the final velocity. And it's in meters per second, so I don't have to do anything to it. And it must start from rest. And I'm looking for the acceleration. So I want to pick one of my kinematics equations. And in this case, there's no time given to me. So I want the one that doesn't have time. And that would be this one, vf squared equals vi squared plus 2ax. And the answer comes out to be 17,361, but it needs to be rounded to 3 sigdigs, so 17,400 meters per second squared. All right, most people did fine on this. They knew that the slope of this graph was your speed or your velocity, and they were able to pick out where you were at rest and when you were moving backwards. And to calculate that speed, you just find the slope of that graph, because you just told me that the slope of it is speed, so that should be a negative slope. And so when you calculate that, you fall 100 meters in 25 seconds. And to find the instantaneous velocity, you would want to find the slope of a line tangent to the point in question. And then in the final graph, I highlighted C and D because you guys were asked to tell me when it was accelerating. Remember, accelerating means speeding up or slowing down. So it starts at 0 and it goes up to 8 meters per second. That's an acceleration. It's a change in velocity. And it starts at 8 and it goes down to 4 meters per second. So that's a change in velocity. So both 0 to 2 and 10 to 12 seconds are our periods of acceleration. And then when it's traveling at a constant speed, it would just be staying at the same speed. In this case, from 2 to 10 seconds and from 12 to 16 seconds. Most of you guys would get one of those, but not both of them. So make sure you're looking at the whole graph. And then finally, B asked you what the area under the curve was. It's the displacement. So if I want to find the displacement, then I'm just going to segment my graph out into areas that I can calculate. So the first area here is half of the base, which is 2, times the height, which is 8. The second area is 8, is 8 times from 2 to 8, 10 is 8, so 8 times 8. And then this would be 1/2 of its base times its height, this length times its width, and this length times its width. And if you do that, you should get a total of 100 meters, and I've worked it out here for you. Each problem was worth a total of 5 points. And if you are really clueless at this point and you're really struggling, it's not going to get any better. We just keep moving forward. And everything in physics builds on everything. So please make sure that you go to the academic assistants and sign up for a tutor if you need one, or contact me and we can arrange to meet online, or you can come to my office if you're in the area. So please, please, please let me know, because you really can't get any further behind than you are now. And then the last thing I want to go over is the lab. And so the lab was your first video analysis lab, and there were tutorials that kind of oriented you to it. Most people did a pretty good job on it. A couple of things that were sticky in the preliminary questions: it wanted you to calculate the average velocity. Remember, the average velocity is the total displacement. So if the car moved, a meter to the right and then a meter back, the total displacement is 0. So the average velocity should not be the same as the average speed here because average velocity is displacement divided by time and not distance divided by time. So you wanted to make sure that you gave me that complete answer. And then the speed of the object is just the magnitude of the velocity. That's all it is. So you just basically repeated these numbers here. That's all you had to do. And then over here, the big thing here was that you understood that in order for the component to have the same magnitude as the speed, they have to be moving in the same direction. The car cannot be, it can only be moving in one direction. But if the car changes direction, its average speed will be different than its velocity because the distance is different than its displacement. And then you went through and you calculated your average velocity. And so basically you just found your displacement and divided it by the time. And you could do that using the numbers on your graph. And then you did that for a couple different things, and you learned how to use the analysis statistics tool, and you answered some questions. And then the thing about reflection is that I wanted to see that you understood is that when the object is moving in one direction, then the average speed and the average velocity are the same. And in B, when the object changes direction, the average speed and the average velocity will be different because average speed is just the total distance over time, has nothing to do with direction, and average velocity is the total displacement over time. So if its displacement is not equal to its distance, then those values will not be the same. So that's really the big point of this lab, was to get you to understand that conceptual information. One word about your discussion: if you would please make sure that you are posting on 3 separate days from now on. You should post your initial post by the due date in the discussion board, which is usually the end of the first week. And then you need to post to 2 people during the next week on 2 different days. So that's a total of 3 different days to get your full participation credit. If you have any questions, please email me and let me know. And some of you guys did wait to the last minute. I think you found that you can't do that in this course. You have to devote a certain amount of time every day or on certain days of the week to physics, so that you can kind of get ahead, and by the second week you can get some questions that you can send me. So take advantage of the discussion board this time and really post some questions. And you make an initial post, but it's okay for you to post another time and say, hey, I really didn't understand this problem. And I do check those posts. I do look at it Monday, Wednesday, and Friday. I look at the discussion boards. So please, please, please communicate with me. And if you made a terrible grade on the homework, then meaning you like totally bombed it, then you need to contact me to get help or make an appointment with a tutor for free at our academic assistance, and I'll be glad to help point you in the right direction for that. All right. You've got 3 assignments due next module. You'll have a homework worksheet like this. You'll have a discussion, and you'll have a lab to do. Let me know what's going on. Have a good week.